Peterson Olefination reaction. Sorry, I lost my voice. So first of all, the first two starting materials are a silicone R3, and then as a reference point, we're gonna have 2 hydrogens, and then the second starting material is a aldehyde. So the point of the Peterson Olefination process is the selectivity of the R1 and R2, whether they're cis or trans to each other. So first, they're both treated, in either case, they're treated with basic conditions. And then secondly, if you want trans, you would have it under basic conditions, and if you want cis, you have it under acidic conditions. So first we're going to go over the first step, which is conditions for both the cis and trans selectivity. And we see a base that comes in, takes off the hydrogen, and its electrons are placed at the center. Those negative charge then attacks the carbonyl, and we see the electrons swing up, and we get this compound. Now is when we differentiate between the cis and trans compounds. So first, in basic conditions, you see here this negative charge on the oxygen directly attacks the silicon compound, and then we see here it creates a quick 4 centered box. Then you swing over, and that is released. And we see here we have the trans. Now, if we're trying to get the cis version of this, right over here, this negative charge attracts a positive charge OH3, which then we have our OH, which then, because of the conditions, further protonates. And we see here, and due to the sterics of the material, we see that there's a switch, there's alteration, there's a rotation of that bond since it is a single bond. Furthermore, because of the likelihood of this silicon compound or part being attracted to a water ion, that it swings down, swings off, and then we see that there is the cis conformation. Thank you for listening. Next, we're going to go over a real-life example. Two starting materials are slightly different than our generic previously shown starting materials, although there is the same carbonyl, and then there is this stabilization factor. So we see here, this is what acts, this is what is deprotonated, then those attack here, and we have this. Rather than this being a negative O, we see that the chlorine is a much easier leaving group, so it just rotates down and is kicked off. Now, our second step of the process is shown here in basic conditions. Hydrogen that's attached here, not shown, is deprotonated and swung up here. Then it proceeds to swing back down here, and this is kicked off. We see that it is in basic conditions, therefore this is in the trans conformation.